Okay, we're going to look at a couple examples where you factor using formulas. So we've looked at factor by grouping and factoring trinomials where you have three terms. And now we're going to look at when you have two terms. And so that would be one example when you would factor would be a difference of squares. And so the general formula would be a squared minus b squared. So that means you have two terms, whether it's a variable or a number, that both can be written as a number or a variable raised to the second power. And the way this factors is you get your parentheses, and it factors to be a plus b times a minus b. So basically your two terms are the same. The only thing that changes is the sign in between. So when you do the opposite, when you FOIL and you had an example like this, you would see that the middle terms would have canceled out, right? So we would have had the outside terms and the inside terms. One's negative, one's positive, and they would cancel out. And that's why you only have a squared minus b squared. So let's use this example. We have x squared minus 81. This is two terms. The only way two terms can factor, or one of the ways it can factor, is if it's a difference of squares. This is a difference, meaning it's subtraction. And both of these can be written as a number squared. So we're going to go ahead and do our two sets of parentheses. For our first term, x squared, it would be x and x. And remember, it's opposite signs, and it doesn't matter which one you put first, whether it's plus or minus. And then what number squared gives you 81? Or you could just take the square root of 81, and that would be a 9. 9 times 9 is 81. So this factors to be x plus 9 times x minus 9. Okay, let's do the same thing with the second one. This is two terms. It looks like it can only be a difference of squares if it's going to factor because of that 2 right there. There's no GCF, so I'm going to go ahead and try and factor it. And starting with our first terms, the square root of 36 is 6, so this would be 6x and 6x. Opposite signs, I'll switch it this time because it doesn't matter which one comes first. And then the square root of 1 is just 1, so this factors to be 6x minus 1 and plus 1. Okay, so let's do the same thing with C. We don't have any GCF, so we're going to factor. The square root of 25 is 5, so for our first terms, we're going to have 5x and 5x. And then for our last term, the square root of 9 is 3, and we also have the variable y squared here, so it's going to be 3y and 3y. Again, opposite signs. Okay, for D, the height of a stone after it is dropped is given by this expression, factor this expression. So the first thing you want to do is take out the GCF, and I would always check, so you have 16 is your smallest number. I would always check first that number, and so divide 256 by 16 and you get 16. So you know that's the GCF. So I'm going to go ahead and pull that GCF out first before I even try and factor this, because you have to do this first. So I'm going to pull out a 16. Remember, that means I'm dividing both terms by 16. So 256 divided by 16 is 16. And 16x squared divided by 16 is just x squared. Okay. Now that I've pulled the GCF out, I have two terms here. This is a difference of squares, so I'm going to go ahead and factor it. Square root of 16 is 4, and the square root of x squared is x, or basically what multiplies by x squared would be x times x. And that's factored.